Hey Logic students, I wanted to go over section 7.6 with you. This is another method to derive your conclusion, and this is called the indirect proof. Okay, so this is how you set up an indirect proof. You're always going to indent. I'm noticing that not everyone is indenting. Please indent. You're going to assume the opposite of what you want to conclude. So just look at the conclusion, put a negation in front of it, and that's essentially what you're doing when you do the AIP. And the AIP means an assumption for the indirect proof. And then you're going to be looking for a contradiction. And here's a few examples of contradictions. And it doesn't matter what it is or how big it is, like this one down here is a not, and this is a not. That's all you're looking for, is some type of contradiction. It does not have to be what you started your assumption off with. It can be anything. Okay? So here's an example. So you're going to start here. Here is your conclusion. And you're going to start with the opposite. So not A is your conclusion, so you're going to start with an A. Now, if we assume that A is true, which is exactly what we're doing when we make it an assumption for the indirect proof. We're saying, what happens if A is true? Well, what happens is you end up with B dot not B, which is 100% impossible. Because you guys remember from chapter 6, that means B is true and not B is also true. That cannot be. There's no world where you can have B and not B both be true. So what that tells us, that is not true. A has to be false, which means not A is the one that is true. And that's how this entire indirect proof works. You start off with the opposite, show a contradiction, and then as a result, you have to know that the other side of the assumption, in this case the not A, that's the one that is true. Okay, so here's another one for you. Again, we're starting with E as a conclusion. Given E, we're going to then do the opposite. We're going to do not E. What we're assuming here is that not E is true. Based on that assumption, we end up with this down here. And this is just complete chaos. Okay, that means this one is true and that one is true. And that cannot be. There's no world where D and not D are both true at the same time. Therefore, we know not E is the one that's true. And by the way, you always add the negation. And then you simply use double negation and you can get rid of it. And also take note, everything inside of here is pretty straightforward. These are all rules that we've been using since 7.2, 7.3. Okay, here's another one for you. Oops, went too far. Okay, so here we have an ACP to start off with, and the reason that we're starting with an ACP is because there's a horseshoe. Now, sometimes a ACP will work with the horseshoe, sometimes an AIP will work with the horseshoe, okay? It just depends on the situation. I would say, as a general rule, whenever your conclusion has a horseshoe, try an ACP first, okay? And if you don't know what ACP is, that's just the assumption for the conditional proof. Okay, and this one is the assumption for the indirect. Okay, so that's why here we're going to start with the ACP. With the ACP, you're always taking the antecedent and starting off. And then your end result always is the conclusion. That's the only way a conditional proof will ever work. You always have to start off with the antecedent, and then you have to end with the consequent. And then when you discharge, you just put it back together. Okay? Let's get rid of some of this. Looks a little messy. Okay, so for this one, we started with E or B, which was our antecedent. And then when we looked over here, we noticed that 1 and 2 of the premises gave us nothing. Okay, so when you have an E or B, the only way you can tear this apart is with DS. So that means we're going to need a not E, or we're going to need a not B. And then when we look up here, we got nothing. Okay, so redirect. Let's see, what can we do next? Okay, so we need an A. We know that. So if we need this A, let's just indent again. And yes, you can do a conditional proof within an indirect, within an indirect, within a conditional. You can just keep going. So we're going to start with a not A because we need the A. And then we're going to see if we can find a contradiction. If we can, we're going to put a tilde on it. And then we're going to have not A, which will give us our A. Okay? So we have a lot of different ways that we can solve these now. So remember again, when you look at the answers that I provide for you, it may not be the way you solved it. And if you have any questions, just email me and I'm happy to help you. Okay? So here, we start with our not A. We end up with B and not B. 100% crazy, no, cannot happen. Therefore, not A is false and A is the one that's true. So here you have an example of an ACP, and then within that ACP, you have an AIP. Okay, so what I want you to do is, based on what you already know, and you know we're using all 18 rules, so that entire sheet that I have for you is a handout, and conditional proof or indirect proof, I want you to pause this video and attempt to do all 4 of these. And then come back and see how I solved it and see how you solved it. Okay, so let's see about solving these now. Okay, so we have a conclusion, and the conclusion is just not A. So there's no conditional, there's no wedges, there's no nothing. So my brain automatically says, let's just do the opposite. And I already messed up. There we go. Now I wanted that button. Okay. Sorry, I'm using a new program. Oh. Never mind. We'll start over again. Okay. So we have not A. Okay, I don't like this program. A. Perfect. So I'm going to start off with the opposite of what the conclusion is. And this is an assumption for the indirect proof. So I'm just going to put AIP over there. And now that I have my A, I can work and start breaking everything down and seeing if I can find a contradiction. So we'll get B from 1 and 3, modus ponens. And then we know we can use this B here with line 2 with DS, but we are going to have to put some double negations on there. And we're also going to have to flip 2. And now I have it set up perfectly. You can look at your handout. It's exactly the way it looks on your handout. Then I'll get not A from 5 and 6, because again, the only way you can tear apart a wedge is that you have to get the opposite of one of the sides. So in this case, I got the opposite of not B, I got not B. Okay? Now the last step is you always want to conjunct the contradiction together. So 3 and 7. And then you discharge, and whatever is up here, you put a tilde on it. And we use 3 through 8, a conditional proof. And we did it. Okay, let's look at this one. So this time we have a conclusion that is a horseshoe, so that means that it is a conditional statement. So my brain says, let's just start with the conditional statement and see what we do. So that means we're going to indent, and we're going to start with the antecedent, and that will be our ACP. Now the goal is 100% right here is your consequent. When we get that goal, we know we're done. So let's start breaking this apart. Okay. So we have F. So then we're going to get not F or D. That's going to be 1 and 2 minus ponens. Then we'll get not D from 2 and 3 minus ponens. And looks like we've already got it set up perfect here. We just need to do 4 com. So now we have the opposite of D. We have not D, and that will give us not E for 5 and 6 ds. And we got it. We needed not E. We got not E. So you start with the antecedent, you end with the consequent. And then that's when you discharge. And then whatever is on top of the conditional proof, that has to go first. Put a horseshoe, whatever is at the bottom has to be the consequent. And this time we used 3 through 7, and we used a conditional proof. Okay, let's look. This time we have J as our conclusion. So my brain says let's just do an AIP and put a negation on it and see what happens. See if we can get this program to work. Okay, so we got not J, so now we're going to do an AIP, and we're just going to start seeing if we can find a contradiction. So that was 1 and 4 minus ponens. And then we can break that down. We'll get just G. We'll do that with just simplification. Remember, you can only simplify with a dot. I'm noticing that some of you are not always following that rule. Okay, that'll give us an I with 2 and 6 minus ponens. And we'll do H from 5. We'll do a com and a simp. Oh, seriously. Okay, and that'll give us our not I from 3 and 8 minus ponens. And we got our contradiction. So now we're going to have I dot not I from 7 and 9, conjuncting them, and then we're done. So whenever you get your contradiction, you can discharge, and then that's when you will put the negation on it. So whatever is here, put a negation on it and put it down here when you've discharged, and then that means over here 12 will just be J from double negative, and here we use 4 through 10, and that is an indirect proof.